In this video, we're going to continue topic 4.5, and we're going to continue our discussion on completing the square. So the very first thing we do here in example B is we first look for a leading coefficient. And I notice that my leading coefficient is just a 1, so there's really no need to divide by it. So I'm going to go on to step 2, which says I'm going to take my third term and I'm going to subtract it or add it to both sides depending upon what I need to do to move it. At the same time I'm subtracting or adding, I add in a plus blank to both sides. Now I'm going to take this middle term and I'm going to set up my skeleton for cheating factoring. And then I'm going to take that middle term and I'm going to divide it by 2. So negative 2 divided by 2 would be negative 1. And then I'm going to square that negative 1, which gives me 1 to both sides. And negative 7 plus 1 is negative 6. And you'll notice, let's just refresh our memory on this. So remember, to get from this line to the next line, what I really did was a magic X. Two numbers that multiplied to 1 and added to negative 2 would be negative 1 and 1. And when I write it factored, we write it like this, so it makes it look like you're super cool, okay? Because you write it squared. All right, I'm going to undo the square by taking the square root of both sides. So I have a plus minus on the right. And then I notice I have a negative under my radical sign, so I know I have to pluck my i's out. The square root of 6 isn't going to break down. We're just going to leave it as square root of 6. I'm going to take that negative 1 and I'm going to add it to both sides. So we get x equals 1 plus or minus I square root of 6. And in this case, since we have an imaginary solution or a complex solution, we know we're going to have two non-real solutions. And then in this reflect for, it asks us how many complex solutions do the equations in part A and part B have, and we are supposed to explain. And we know that they each had complex two solutions, right? This one had two solutions. They happen to be real solutions, but real solutions are part of the complex number system. This one had two non-real solutions, and again, those are both part of the complex number system. So we would want to write down that each had two complex solutions because complex numbers include real and imaginary.